So good morning everyone. Today in this class the subject is the digital electronics and computer architecture. We are going to discuss basically different type of operating system. That's the introduction part of a computer architecture part. Okay. So first of all, what is the role of an operating system? We all heard about the term the operating system, which is related to the any computer system. So operating system basically it is a system software which runs to, to which is generating a platform in which the other application software is used or to handle the resources, the hardware resources of any computer system. The hardware resources may be the input devices, the output devices, the printing facility of any documents, or the displaying any image or any video or picture. Okay, so whatever the user is going to apply any application software, the application software ultimately works on the operating system. So an operating system is a foundational software that manages computer hardware. So operating system manages the computer hardware and software resources and provides services of computer programs. Okay. So we can say that operating system acts as an intermediary between the user and the computer system. It manages hardware resources or provides the user interface and enable the execution or other application programs. So by definition, if we say the definition, what is the definition of an operating system? So an operating system is a software that manages computer hardware and software resources and provide common services for computer programs. Now, if we focus on the main functions of an operating system, first of all, the process management. Okay, what is process management? What is the function of process management? Process management first of all handles creation and scheduling and termination of processes, which is called the running programs. Another function of process management is that which allocates CPU time and processes. So it allocates the CPU time and processes. Another thing a process management does ensures synchronization and communication between different processes. So a computer may work on different programs at a time. So the process management ensures the synchronization and communication between different processes. Okay. Another function of an operating system. So first of all, the function of operating system is the process management. Another function is the memory management. Okay. So how the memory management does by the operating system? Operating system keep tracks of each byte of computer memory. The memory may be hardware, maybe in a hard disk or in a RAM or a cache memory, any type of memory. So the memory management keep track of each byte in a computer memory. Second thing is that memory management allocate and deallocate memory space as needed by the different type of program. Another function of memory management is handles virtual memory to run large program on limited physical memory. So suppose in a computer there is 2 GB of RAM, but if we want to run or want to execute in an application program which may be around suppose 4 GB of needed 4 GB of space, so the additional 2 GB of space is allocated from the operating system, from the hardware, and it looks like it is a part of the memory. So that's why it is called a virtual memory. So memory management handles the virtual memory to run large program on limited physical memory. Here physical memory means RAM or cache memory. Another function of operating system is the file management system. So in file management system, the operating system manages data storage in files and different files and directories. Different files and different directories, the operating system manages the data. Another thing the file management handles creation, deletion, and read-write operations. Also, file management system provides access control and security. Okay, so these are the different functions of a file management system in operating system. Another function is the device management. Okay, so operating system manages device communication via drivers. Suppose, for example, keyboard or mouse or printer. Also, in device management, operating system controls the I/O operations, input-output operations, and it maintains queues and access permissions. Another function of operating system is the user interface. In user interface, it provides a command line interface or graphical user interface. Also allow user to interact with the computer easily. Okay, so these are different type of different functions of an operating system. If we know the different type of the operating system, what are the different types of operating system? First of all, the batch operating system. So in batch operating system, the user does not connect directly with the operating system. So no direct interaction with the user. Jobs are allocated and processed in batches. So it's not a single task, it is a bunch of tasks. So jobs are collected and processed in batches. This is the batch operating system. Another thing is time sharing operating system. What is time sharing operating system? Time sharing operating system allow multiple users to use the system simultaneously. Okay, so here CPU time is divided among the user. This is called time slicing. Okay, another type of operating system, the distributed operating system. In distributed operating system, it manages a group of computer and makes them appear as one system. So, for example, that is cloud computing system. Okay. Next thing is the real-time operating system. So it processes data instantly and responds within a strict time limit. It used in a system like air traffic control or medical devices where real-time data is needed. Another type of operating system is the multi-programming operating system. So multi-programming operating system allows user more than one program to run concurrently using the CPU scheduling. Okay, so it is called multi-programming. As the name suggests, multiple programs runs on the same time. So it allows more than one program to run concurrently using the CPU scheduling. Also, there is another type of operating system, that is mobile operating system. Okay, so this is specially designed for the mobile devices. For example, Android, iOS, these are the different type of mobile operating system. Next we go. The next topic is the compiler and assembler. So okay, so first of all, compiler. A compiler and an assembler both are translator, but they operate on different level of programming language. A compiler translates high-level programming language like Java, C++ into machine code. Okay, so a compiler is a program that translates a high-level programming language like C or Java or Python. These are the different type of high-level programming language, and it converts these high-level language using compiler converted into machine-level language. For example, binary code zero, a combination of zeros and ones. These are the binary code and also called a machine language. So a compiler converts the high-level programming language into a machine-level language, so the computer can understand and execute it. So what is the if we go to the definition, what is the definition? So a compiler takes a complete high-level programming and convert it into a machine code. Okay. Now, what are the key features of a compiler? First of all, in compiler, input is high-level language like C, C++, or Java or Python. What is the output? Output is obviously a machine code, as we say, machine code which is executable binary code. If we and another feature, if we go through, is the translation time. So the in compiler, this is the difference between compiler and assembler. What the compiler does, in compiler the entire program is translated before execution. Okay, so before execution, the entire program is translated. If we go to speed, it is faster during execution but slower during the compilation. Example of different type of examples of compiler is the GCC compiler or Java C or Turbo C. These are the different type of compiler. Phases of compiler. What are the phases of compiler? Different type of phases are there. We will go in discuss later. The lexical analysis phase, syntax or semantic analysis phase, intermediate code generation, optimization, code generation, or code linking and assembly. These are the different phases of a compiler. We can discuss all these in details in later period. Now, if we discuss about the assembler, what is assembler and what is the difference with them with the compiler? So an assembler is a program that translates assembly language, that is a low-level human-readable form of machine instruction into actual machine code. Okay. So definition is that an assembler convert code written in assembly language into a binary code that the CPU can execute. What are the key features of an assembler? So what is the input of assembly language program? What is the input? Input in assembler, input is assembly language program. As we, for example, in microprocessor, we use a command, suppose move A comma B. Move A comma B means the content of B is moved to the content of location B is moved in the location A. This is the move A comma B. So move A comma B is a assembly language. And in this case, what is the output? Output is a binary code or binary machine code. How the transition is going on? One-to-one mapping from assembly to machine language instruction. So in compiler, the translation, the whole program is translated once, but in assembler, only one line of code is translated at a time. So as we compared with the compiler, the speed of the assembler is very fast. So translation is very fast, and it is used by system level programming, embedded systems. In these cases, the assembler is used. If we compare both compiler and assembler, so first feature is the input language. So in compiler, what is the input language? In compiler, the input language is a high level language, that is C, Java or Python. These are the high level language. It is input as a compiler. And in case of assembler, the input is the assembly language. Just given an example before, that is move A comma B. This type of code is the input of an assembler. What is the output? In both cases, output is the machine code or binary code. If we go to the abstraction level of compiler is very high and assembler is very low. Okay. Translation speed is slower compared. In the case of compiler, the translation process is slower compared to the assembler. Output file type. Okay. In both cases, the output file type is the executable code or the object code. Okay. In the both cases, the output is the binary machine code. Okay. If we compare the error handling, now we're going to discuss the fetch, decode, and execute cycle. Okay. So the fetch, decode, and execute cycle is the fundamental process by which a computer CPU executes instructions. It involves three main stages: fetching the instruction from memory. First of all, the fetching of the instruction from memory. Second is, as the name suggests, decoding the instruction to understand its meaning. And at the last, the executing the instruction, performing the specified operations. So actually, fetch, decode, and execute cycle is also known as the instruction cycle. Okay? So it is the basic operation cycle of a computer CPU that happens every time the process runs an instruction from memory. What are the different phases of a cycle? First of all, the fetch cycle.